Morning. Good morning, students. Now let us continue from problem number 5, Bayes theorem. So fifth problem I am going to read. You please listen and then we'll write everything on the board. A laboratory blood test is 99% effective in detecting a certain disease when it is in fact present. However, the test also yields a false positive result for 0.5% of the healthy person. If 0.1% of the population actually has the disease, what is the probability that a person has the disease given that his test result is positive? Okay. So, basing on this, now we are going to do now problem. So, what is given in this here? He has given a laboratory test we are doing in that. So, blood test we are doing in the laboratory, we have to see that it has disease, not disease. This is the sample space. Okay, as you know that here sample space has what? Two is split into two events. What is that one? First one is E1 is the blood test having positive, E2 disease, non-disease, like this is better to say that. Two events are what is that? Disease, having disease, having non-disease. Non-disease fellow means healthy, which you don't have disease means healthy. So this is the two events are there. So from this we came to conclusion that we have two events here. What are those two events? Let us write now here. Okay. Now let E1 and E2 be the respective events that a person, I will write here. Let E1 and E2 be the two events. Nothing is there. What is given in statement, that only I am writing. So nothing. Let E1, E2 extra only I am writing. Let E1 be E2 be the two events. Let E1 and E2 be the two events, respective events that a person has. Two events that a person has. First one is what is given. We'll see. Disease or not disease. Disease has a disease. Person has a disease. So one event is person. First event is what? Person has a disease, and a person has no disease. And a person has no disease. And person has no disease. So this is another one. And person has no disease. So events are divided into two parts now. What is that? E1 and E2 be the events that a person has a disease and a person has no disease. No disease means healthy. So two events is given in that sample space. We have to write the probabilities, This implies what is P of E1, that is important. What is P of E1, you tell me? A person who has a disease given 1%, 0.1% is given that according to the statement. 0.1% means how much? 0.1 by 100. 0.1 by 100 is 0.001. 0.1 by 100 means what? 0.001. That is the E1. Next, what is E2 now? You tell me. I'll write here only. And E2 and probability of E2. What is probability of E2? 1 minus 0.001, that is equal to 0.999. Correct? Why, sir? I don't know why you are subtracted for it. See now, I'll tell you. Here, E1 and E2 be the events that a person has a disease, has a no disease. Has a disease and has a no disease, you have anything common? Disease, having disease is different, having no disease is different. They are mutually exclusive. They are disjoint events. So there are only two events in a sample space. Therefore, if you add those two, entire sample space will come. What is the probability of a sample space? 1. So 1 probability, if you know it, what is the other probability? 1 minus of the known probability. So we know P of E1 and E1, E2 are disjoint events if their union is entire sample space. So therefore probability of E2 is equal to 1 minus P of E1. What is P of E1? 0.001. That is equal to 0.999. That is how you have to find out. Okay, my dear friends. So even is events are over. Now what is there? What is the common event associated with the events in sample space? Let A. Correct? So what is asking A now? Let's see in the book. Let A be the event, that a blood test. We'll write here. Let A be the event. Let A be the event. Let A be the event blood test. Okay. Let A be the event blood test. Let A be the event that the blood test result is positive. Event that we'll put that the we'll put like that the blood test result, I'll write here, result is positive. That is the common, that is the associated with sample space. So whatever be there, A means what? Let A be the event that the blood test result is positive. Once you know this, what you have to find out now? This implies P of A given E1. It should be a person who has disease, is a disease. That fellow blood test should be positive. The probability that a person blood test is positive given that he has a diseased fellow. So I am not writing because you know what is A, you know what is E1, you know, you can predict that. Directly I am writing the value. So what is P of E1 now? A given E1, it is nothing but 99% according to the statement. 99% means what? 99 by 100. 99 by 100 is how much? 0.99. What is the meaning of this? Probability of A given E1 means probability result is positive given that the person has a disease. That is the meaning. Next, what is probability of A given E2? You tell me now. I already told now. Probability result, probability of result of a person, result is positive given that his test results is positive. That is the second one. How much is given? 0.5%. 0.5% means how much? 0.5 by 100. 0.5 by 100 means what? 0.005. So this is in terms of 0, you have completed. Now, so what is the probability you have to find out now? That you have to see. So what is the event you have to find out now? The probability, and we'll read now. What is given, that we'll write. What is that? I'll write here. The probability according to the statement. The probability. The probability that a person. The probability that a person has the disease. Has the disease given that as a disease, given that his test results is positive, given that his test result is positive, given by, given by. I will write now, reverse process, probability of even given A, that we will write. So even test which is positive, we will write that only, even given A. If you write that, it is over now. So probability of even given A means you know how to write. I will write here. That is by Bayes theorem, probability of even given A is equal to probability of even into probability of A given even by, again the same total probability of even into probability of A given even plus probability of E2 into probability of A given E2. That is the problem. Okay, probability of given plus probability of A given. So now the values you substitute here. Probability of even, you see the problem, 0.001, 0.001 into probability of A given even, how much? 0.99 divided by probability of even, same, 0.001 into 0.99 plus probability of E2, 0.999 into how much? Probability of A given E2, that is 0.005. Okay, now you just multiply and see that here 199, here 3 plus 2, 5, 50 should come. And how much will come? 5 points means 1, 2, 3, 4, 5. After decimal point, totally 5 digits must be there. So here 3 is after decimal point, how many digits are there? 3. Here how many are there? 2. 3 plus 2, 5. So 5 must be there. But 1 into 99, 99. Remaining 3 zeros. That's why you put zeros. The same you write here. 0.00099 plus. Now you multiply and check it. 0.99 into 5. 9 5 just 45. Like that you multiply and check it. How much you are going to get, my dear student? We have to see now. So therefore, finally how much you are going to get means, if both are there together, if you multiply and if you see that, if you multiply and see what is there, 9 5 is 45. 9 5 is 45. Again 9 5 is 45 plus 5, 50. Sorry, I'll write here 999 with 5. 9 5 is 45. 9 5 is 45 plus 4, 49. Yes. 9 5 is 45 plus 4, 49. So 9 5 is 45. Again 9 5 is 45 plus 4, 49. 9 5 is 45 plus 4, 49. 4995 has come. So what you will write now? The number how much you got, that you write here. It is 4995. But after digit how many are there? After 0 point, after how many digits are there? 3. Here how many are there? 3. Totally 6 digits must be there after digit point. 1, 2, 3, 4 all is there. 0, 0, 0.0. So it is nothing but 0. Okay na? 004995. How much totally? Now 0.00099 by, if you add together, how much you are going to get? You see, 9 plus 5, 14. So if you multiply and see and you find out 0.005, if you multiply and see 0.005985, 0.005985, you totally you multiply and add and you will see now how much you will get, you see. Okay na? So therefore, what is the value? 9. So if you simplify, 990 by, here 6 are there, 5 are there means 0 will put 5985. My dear students, directly I will write the answer. After simplification everything, 9 will go table, 110 by 665. 9 table will go 110 by 665. Again I feel 5 will go, 2 5 is 10. Again 2 5 is 10, 22 by 1 5 is 5, 16, 3 5 is 15, 133. 22 by 133. So therefore, that is the probability. So whatever you are doing previously, that only you are doing. First of all, sample space. In that, how many events are there? So what is the respective probabilities? What is A and what is A given even? What is A given E2 and what probability asked? Write the formula, Bayes theorem, substituted and simplified. Okay na? My dear students, I think you understood. Let us move to the next problem. Problem number 6. Okay, so this is all we are given. These are all you are given. Why you are given means to know it, because applications, everything will come now. So let us move to the next problem. We will see now. Shall I rub it off, my dear students? Okay. You got it? You simplify and see now. Okay, this is problem number 5. Before that we did 4, now it is 5. Let us move to the problem number 6 now. So, why I am writing working means we should write like this in examination. Directly if you put values, no use. So, that is why we should say what is E1, what is E2, that is important. What is EA, then you can write. If these three are compulsory important, how many events are there, what are representing that. So, that is compulsory. And what is EA? If these three is minimum, remaining if you do not write also no problem, but these three minimum, and finally formula is minimum, and then we will get the 5 marks if it is given for 5 marks. Okay. Now, let us see the problem number 6 now. Problem number 6. What is given here? There are 3 coins. Problem number 6. There are 3 coins. One is two-headed coin having head on both faces. Another is a biased coin that comes up heads 75% of the time. And third is an unbiased coin. One of the 3 coins is chosen at random and tossed. It shows heads. What is the probability that it was a two-headed coin? Okay. My dear students, you are very known that in a sample space now 3 events are there. 3 events are there. E1, E2 and E3. What is E1? Two-headed coin. What is E2? Biased coin. What is E3? Unbiased coin. It is very clearly given in the test problem, so that is easy. So, E1, E2, E3 sample points. If these three add, you will get the entire sample space. Therefore, E1 is two-headed coins, E2 is a biased coin, E3 is a unbiased coin. Respective probabilities are given. We will write now. Now, how we will write now? Let E1, E2 and E3 be the respective events. We will write now. Let E1, comma E2 and E3 be the respective events. Now, what I said, the series is correct only, but once again let me check. Respective events of choosing. Okay, what you are choosing now? A, choosing a two-headed, first one is two-headed, choosing a two-headed coin, that you write. Choosing a two-headed coin. What is given, that only I am writing now. Nothing I am writing any new headed coin. What is the next one? Comma, I think biased, two-headed coin, a biased coin, correct. A biased coin. And an unbiased coin, and an unbiased coin. Okay, now this is the important one. So this is important. You should write what is E1, what is E2, what is E3. So let E1, E2 and E3 be the respective events of choosing a two-headed coin, a biased coin, and an unbiased coin. Unbiased coin. Whatever you want, you can do it, no problem. So, an unbiased coin. Oh, now you tell me. Here you should not get confused. He has given two-headed coin, unbiased coin, biased. Okay, the properties of the coin he has given. Okay, na? Here one coin is there, here one coin is there, here one coin is there. So, first of all, what you have to do? You have to select one of the coins. You have to select one of the coins means there are equally likely only. Out of 3, you have to select one means 1 by 3 only. So, therefore, this implies, here you should not get confused, my dear students. Therefore, P of E1 is equal to P of E2 is equal to P of E3. All are same only. All are same means how much? 1 by 3. P of E1 1 by 3. Selecting a two-headed coin from 3 coins is 1 by 3 only. Selecting a biased coin from 3 coins is 1 by 3 only. Selecting a unbiased coin from 3 coins is 1 by 3 only. That's why P of E1 is equal to P of E2 is equal to P of E3 is equal to 1 by 3. So, our first part is over. What is the second part now? Let A be the event of, what is the A? Getting a two-headed coin, heads only. So heads only we want. Let A be the event that the coin shows. We write like that. Let A be the event. Let A be the event that coin shows. That coin shows heads. That A be the event that coin shows heads. That you want. So in that coin, whatever you say, that is head only. So now you tell me what is you have to do now. Probability of A given even. My dear students, what is A? Coin shows head. What is even? 3-headed coin. We want head. It is already headed is there. What is the probability now? 1 only. Correct? We want head. It is a 2-headed coin. So what tail won't come, So therefore, the probability of A given even is equal to 1. Next, probability of A given E2. Biased coin is said. Biased means more number of times head will appear is said. More number of times head will appear means how many times? 75% is said. Okay, 75% means 75 by 100, which is nothing but 3 by 4. Next, probability of A given E3. E3 means unbiased. Unbiased means what? Equally likely. Chance of getting head and tail are equal. Therefore, probability of A getting head getting in when unbiased coin is chances are equal likely 1 by 2. That only it helps. So it is totally head coin only. You cannot get tail. So the probability is certainty 1 only. If a 2-headed coin, if you toss, what you are going to get? Head only. So therefore that is probability of certainty. So probability of 1. Here what happened? If you toss a coin, the chance of getting head is more. He said 75% times head will get head. So therefore the getting head is 75 by 100. But here what? No, unbiased. You toss it, the chances are equally likely. So equally likely means what is getting head is 1 by 2. So that's what you have written now. Okay, my dear students, I think you understood now. P of A given even, P of A given E2, P of A given E3. Now what is your probability? What you are asked to find out, that you write now. Probability, the probability that the coin is 2-headed. Right, the probability that the coin is 2-headed, given that 2-headed, given that. Now what is given, what is asking, from where you want asking, that you have to see. Given that the probability, the 2-headed coin, given that it shows heads, given that it shows head, given that it shows head, it shows heads, is given by, I will say reverse probability of even given A. Shows head means first event only. So that's why even given A over. Now we have to see the problem now. Even given A, you know how to do. I need not tell you. From there it is by Bayes theorem. By Bayes theorem. By Bayes theorem, you write the formula now. P of even given A is equal to P of even into P of A given even by P of even into P of A given even plus P of E2 into P of A given E2 plus P of E3 into P of A given E3. So now that's now substitute the values. What is P of even? 1 by 3. What is P of A given even? 1 by 1 by 3 plus 1, sorry, into 1 plus, now 1 by 3 into what is P of A given E2? 3 by 4 plus 1 by 3 into P of A given E3, 1 by 2. Simplify it now. This is nothing but 1 by 3 up, 1 by 3 take common, you are going to get 1 plus 3 by 4 plus 1 by 2. So 1 by 3 cancel. So 1 by LCM is 4. In 4 times will go 4 plus 3 plus 4. 2 goes in 4 times. 4 into 2. Sorry. 4 into 2 into 1 2. So this is nothing but 4 by 9. So 4 by 9 is the probability of getting two-headed coin, and head is always needed. That's all. This is the problem. You understood? Easy only. Nothing is there in this. You know it. Whenever is a three-headed coin, 3 are there means 3 events. Their probabilities. What is A? What is A given E1, A given E2, A given E3? What required probability? Reverse. Formula is total probability. Whatever exactly you want by total probability. Substitute the values. We got it. Once you know the same manner, it is easy for you to do the problems. Okay, let us move to the problem number 7 now. Let us move to the problem number 7. Okay, now if we move to the problem number 7, so what is the problem number 7? We'll see now. Problem number 7, again what is given? Let us see now. I'll read the problem number 7. An insurance company insured 2,000 scooter drivers, 4,000 car drivers and 6,000 truck drivers. The probability of an accidents are 0.01, 0.03 and 0.15 respectively. And the first scooter, next car, next truck drivers. One of the insured persons meets with an accident. What is the probability that he is a scooter driver? That he is a scooter driver. That is what is given here. Okay. So now, anything you want to do, insurance you have to do. That is what he is saying now. Whenever insurance you have to do, how many people are insured like that is asking. He said that there are 2,000 scooter and 4,000 car drivers and 6,000 truck drivers. So how many events are there totally now here also in sample space? 3. So let E1, E2 and E3 be the respective events. Same unless you have rubbed it. Let E1, comma E2 and E3 be the respective events. What do you want now? Respective events. That the driver is a scooter driver. Okay. Events. That the driver is a scooter driver. Next one is what? Car driver and a truck driver. All given in statement, that only I am writing now. So let E1, E2, E3 and be the respective events, that the driver is a scooter driver, car driver and a truck driver. So 3 events are there. So from these 3 events we have to find out their probabilities now. Okay, I'll write now. This implies what is P of E1? In the statement nothing is given, sir. Nothing is given means total insured persons how many are there? 2,000 scooter, 4,000 car, 6,000 truck means total 12,000 people are there. Out of 12,000 how many scooter drivers are there? 2,000. So 2,000 by 12,000 is nothing but the probability of scooter drivers. So therefore we will write now 2,000 by total number of sample points 12,000. It is nothing but 2 by 12 or 1 by 6. In the similar manner, P of E2 car drivers, there are 4,000 are there. There are 4,000 out of 12,000. Total insured persons are 12,000. So therefore here will go means 4 by 12, which is nothing but 1 by 3. And next, and P of E3 truck drivers are 6,000. 6,000 by 12,000, which is nothing but 1 by 2. Directly I wrote. So the probability of E1 is 1 by 6, E2 is 1 by 3, E3 is equal to 1 by 2. Now A you want. What is A? Met with an accident. A fellow which has met with an accident is nothing but A. So let A be the event. Let A be the event. Who? The driver. Let A be the event. That the person meets with an accident. That the person meets the accident with an accident is accident with an accident. That's all. That is the person. So now you have to tell me now. That is A. This implies P of A given even means the person who met with an accident must be a scooter driver. So how many are there? How much is given according to the he has given in already. He has already given, you see. He has given that 0.01. He has given 0.01. You write that 0.01. Next, probability of A given E2 car drivers. Their probability is 0.03, and truck drivers, the probability of met with an accident, but chances, probability of A given 3 is equal to 0.015. That's all. So he is already given everything, so it is easy. So this is important problem. Generally, so many times it is given now. So now the probability that the driver is A, the probability finally, the probability that the driver is a scooter driver, given that scooter driver, given that what is given that, you tell me now. Given that he met with an accident, so the person who met with an accident must be a scooter driver. Is given by working principle, sir. Hertz, probability of scooter means even given A, reverse probability. So by Bayes theorem, you should write like that, by Bayes theorem. Which theorem basing on doing the problems, you should write that. Which Bayes theorem? Okay. Probability of even given A is equal to probability of even into probability of A given even by. So three persons are there, you write total probability of even into probability of A given even plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3. I need to write everything because you know it, but simply I am writing because it must be, what is 1 by 6 probability of even. 1 by 6 into A given even is how much? 0.01. 0.01 means how much? 1 by 100. You write 1 by 100 directly, I am writing now. So 1 by 6 into 1 by 100 plus probability of E2 1 by 3 into 0.03 means 3 by 100 plus 1 by 2 into 15 by 100, 0.15, that means 15 by 100. Okay, now simplify it. Simplify means 1 by 600, keep like that only. Here also, down also you take 600 LCM only, then it is easy. 600 goes in 600 one time. Here 300 is there, 300 goes in 600 two times. 2 into 3, 6. 600 goes, 200 goes in 600 3 times, 3 into 15, 45, 600 cancel, so totally 1 by 51. So that's why the probability of getting accident, a scooter driver, an accident occurred is 1 by 51. 51 accidents occur means 1 may be scooter according to the probability. Okay. Oh, this is the very important problem. I think you understood. Nothing is there. Nothing is there. Sample space, how many are there? All mechanically now we came to know that. Let us do the next problem now. Now problem number 8 now. Problem number 8. We'll do now problem number 8. Okay. So once we do the problem number 8, we'll come to know. Okay. Let us see what is the problem number 8. What is given? Let us see now and we'll write it. Problem number 8. A factory has two machines, A and B. Past record shows that the machine A produced 60% of the items of output and the machine B produced 40% of the items. Further, 2% of the items produced by machine A and 1% produced by machine B were defective. All the items are put into one stockpile and then one item is chosen at random from this and is found to be defective. What is the probability that it was produced by machine B? So, now what is happening? It is in a factory. In a factory, what is happening? How many machines are there? Two machines are there. So there are two events. That's all. Two missions. A and B is said, that's why there are two missions are there. What is the mission? Let E1 and E2 be the respective events. I'll write like that. That is common word. Let E1 and E2 be the respective events. Respective events. Now this is common. So now what is given in problem? We'll see now. Respective events of items produced by machine A and machine B. Machine A and machine B. There are two only are there, machine A and machine B, or by machines A and B, like that also you can say. Okay, now I'll write let X. Now here let X. Generally what you are doing now? Probabilities there, E1, E2 probabilities. Okay, this implies probability of E1 is already said. The capacity of the machine A is 60% and means 60 by 100. 60 by 100 means 6 by 10 or 3 by 5. The probability of E2 by machine B 40% and 40 by 100, that is called 4 by 10 or 2 by 5. Over. So 3 by 5, 2 by 5 according to the given statement. You see, he already there 40%, 20% is already given means we wrote. Now let X be the event, that the produced item. Let X be the event. Let X be the event that the produced item, is produced item is defective. He is asking defective. It should be a defective. That's X. Sir, every time you are saying A, now why you are changing it, sir, X? You are saying every time A only, no? Okay, it was the produced item was to be defective. Item is defective. Okay. Why you are, sir? Because already machine A, machine B are used, Here A and B are used. That's why I don't want to use A. You will get confused. That's why in place of A, I took X. Now what you will get now? Probability of. In place of X given A, X given means X, probability of X given A1. How much he has given defective items? From the problem only it is there. It is given that probability of X given A1 2%. 2% are defective, he said. 2% means how much? 2 by 100. Let it be like this. Probability of x given E2. How many are defective? He said in 2. 1%. I'll see now. He has given that in this 1%. Correct? 1%. 1% of defective means how much? 1 by 100. So what is given from the statement only I am writing now. 1% is given, it is 1 by 100. Defective items. So now what you want finally? What you want from this? You want the probability that the randomly selected item, the probability that randomly selected item is randomly selected item is what? What do you want? Is defective. Randomly selected item, he want item was from mission B. Item was from mission B is given from statement. From mission B, given that it is defective. Given that it is defective. How will represent? Comma is given by. I will present P of E2, E1 given X. Where is the see now? That is we will write now. E1 given X. So E2 given X, I think defect mission B. Mission B means E2. E1 means A. So E2 given X. So what we will write now? By Bayes theorem. What we will write now? Probability of E2 given X is equal to probability of E2 into probability of X given E2 by probability of E1 into probability of X given E1 plus probability of E2 into probability of X given E2. That's all. So therefore, the respective probabilities you write probability of E2, my dear student, 2 by 5. Into probability of X given E2, 1% means 1 by 100 by what is probability of given E1? 3 by 5 into X given E1 2 by 100 plus 2 by 5 into 1 by 100. So totally how much you are going to get now? 2 by 500 by, again you take LCM 500. So what you are going to get now? 3 2s are 6 plus 2. Here 500 cancel. So therefore it is nothing but 2 by 8, which is nothing but 1 by 4. The probability of getting a defective item from mission B is how much? 1 by 4. Okay. Now remaining problem also you can do, but anyhow in next class I am going to tell you. In the meanwhile, just 4 as already previously 4, now today's 4, 8 problems. You please do it. 100% will come to know. Another 4 problems are there, will complete it. Okay, my dear students, please practice it. Thank you.